So hello everybody, here is a little video about how to create array data from an example. So we will also take profit to make a little reminder of how to build this array data. So as private values written in red, one has to choose two prime numbers. So let's choose P equal to 23 and Q equal to 17. So actually, this is an example where we actually are building our key set to produce it for someone else. So first of all, we can calculate n, which is equal to P times Q, which is 391. So this is the first part of the key. Then, in a private way, let's compute phi of n, which is P minus 1 times Q minus 1, as P and Q are prime numbers. So calculating phi of n from P and Q is easy. It's 22 times 16, which is equal to 352. Next step, choose some exponent e, which is also public and has to be prime, relatively prime, with phi of n. So let's choose, for example, e equal to 43. This is actually the public key. So now I can publish this couple to allow people to send me a ciphered message. On the other hand, I have to calculate my private key, which is D, which will help me decipher messages which will be sent to me. So D is the inverse of E. So 43 with respect to phi of n. So take care that D is related to E with respect to phi of n, not to n. So if we do the calculation actually using the extended Euclid algorithm, we'll find that the value of D should be 131. So all is set up there, so we can publish n and e as public key and keep the value of D to decipher messages. So how does this work? Now, for example, let's say that I publish n and e, and then someone, so anyone getting the public key, actually it can be anyone because the key is public, someone wants to send a message m. Let's say that m is equal to 164. Then, to cipher this message, this person will use the public data to cipher. So, the value cipher message C is equal to m to the power of e modulo n. So here, let's replace with numerical values, 164 to the power of 43 modulo 391. So that's the way that calculation is done. So actually, the result will be, after some calculation, 284. So if a person wants to send me the message 164 using my public key N and E, will compute the cipher message as 284. So next step, let's say that I get C, which is equal to 284. The purpose is to decipher this message to get back to the value of m. So on my side, actually, I will calculate m as C to the power of D modulo n. So actually, I'm supposed to be the only one to know D, okay? So let's compute that, replacing by numerical values. Actually, the value will be 284 to the power of 131 modulo 391, and actually you can try to do the calculation by yourself. The result is 164. So here, actually, using the deciphering step, I get back to the original message that has been ciphered using my public key.